Hi, welcome tonight at the Codebeez Meetup. It's the 11th of June. It's 6 p.m. Central European time, and we got two nice talks for you lined up. Both are in English, so if English is a problem, then we suggest translator. But the first talk will be with Timothy. So we got the program here. One sec. Yeah. This talk is about how to implement Buzzword. So it's about all the hype that's been around the cloud, and Timothy's a real fun guy. So I'm looking forward to that. There will be a 10-minute intermission, then followed by a fellow Codebeez, Daniel França, and his title is Django in Serverless Land. So we got Django, we got some serverless lambdas on, for instance, AWS, and there will be some magic called Zappa, and he will talk all about that. He's a real cool technical guy, so yeah, very knowledgeable. Two very nice talks. My name is Luc van der Velde. I'm a Codebeez at Codebeez. You can find us at codebeez.nl. And with this, I want to introduce Timothy with the first talk. I'll switch slides first, just a sec. There we are, the first slide. Now for the camera pass. Timothy, take it away.
Okay, is that fine? Cool, thanks, Luke. So, as Luke said, I'm Tim, and I'll be talking to you about how to implement Buzzword. I changed the variable Buzzword to any kind of Buzzword your colleagues or any industry expert is currently using and talking about. So before I go into that, I'll talk a little bit about myself. As I said, my name's Tim. I work at Skyworks, and I'm a cloud engineer. Skyworks is a boutique consultancy company which partners with clients from the small startup to the big multinational companies. They partner with those clients to tackle issues in the cloud and using cloud technology, but mainly we try to instill a mindset, a cloud native mindset where they can future-proof as much as possible their technology stack. I'm originally from Malta, hence the funny accent, and I'm sure you'll still understand me. And I consider myself a bit of a realist. Maybe some of my colleagues say a bit of a cynic, maybe hence the title into my presentation of how to implement Buzzword and infuriate pretty much everybody in the company as you do that. So after the presentation, a bit of an overview. It's split into two parts. The first part, I want to tell a story. I think all great presentations should have a story, hence I'm going to have mine. And after that, hopefully you could learn something from the story. I mean, if like in any story, you should learn from it. Like similar to the story of Harry Potter, what you can learn is that Dumbledore was extremely biased towards Gryffindor. So hopefully you could learn something from the story. So our story begins with Hip Company. So Hip Company is this up and coming startup. It's everybody's talking about it. You've all kind of heard about a hip company. They're the kind of company that has a ping pong table in one of the rooms. They put it into a meeting room. You can see there. It's a meeting room. They've got a whiteboard. People go on it and have a ping pong table there because they're hip and up and coming. They also have a Switch. They've got a console, either a Switch or a PS or a Xbox, just for people to have fun and play around because they actually play. They don't just work And they also, just like every other hip company, they do Friday drinks. Look at the couple there. They're having fun. They've got a variety of beers, and they're actually really having fun. Hip company is the company to work for. In essence, hip company is the work hard and play harder kind of company. I love this slogan. I think the recruitment manager who came up with this had a stroke of genius, and he said, "Yeah, who doesn't want to work extremely hard and then play even harder, put in more energy after a week of extremely hard work?" So hip company is the place to be. But our story goes, hip company is scaling up. It's getting bigger and bigger, and hip company is actually becoming more of a boomer kind of company. It's got a monolithic application, and you know, monolithic application. You hear Space Odyssey team in the background as soon as you hear monolithic. It even sounds ominous, monolithic. People are telling them you shouldn't use it. It's a legacy kind of system. So they've got a monolithic application, and nobody wants to really work on monoliths anymore. Bug fixes are taking ages, which cause more bugs in the system. Deployments are on a 3-month basis, quarterly basis, where you've got a release manager who comes into the company, stays in the corner, shouts 3, 2, 1, and everybody presses the button, SSHs into the VM and deploys, and obviously things go interesting there. And your dev and ops teams don't really talk to each other. Even is there even an ops team? Fred maybe one day decided to use an S3 bucket in AWS, so he's now become the de facto ops person to talk to. So hip companies starting to move into that boomer section, and hip management are shaking their heads like, what can we do? How can we become hip again and make sure that everybody wants to work for hip company and wants to work for us? So they scratch their heads. They're all into their meeting room. You can see they've got laptops. They go onto the internet, search and try to see what's the next big thing. What should we be using? So they obviously search the internet, and they find that stroke of genius to say, yes, this is what we're going to do to become hip again. They're going to implement microservices. Everybody wants microservices. You want microservices. I want microservices. Luke wants microservices. Everybody's doing microservices. So hip company is going to implement microservices. So our story is going to take us into this wonderful world of microservices. Bit of a proviso there, and kind of a spoiler into the story. It's not really a microservice. It's going to be a distributed monolith. Yeah, this is when you should shudder. If you hear distributed monolith, run away as quickly as possible. So hip management says, yep, let's go. Let's implement microservices. As I said, everybody's talking about it. Martin Fowler from ThoughtWorks has an unlimited number of blogs about microservices. Kelsey Hightower, I'm a big fan of Kelsey Hightower. Even he presents about microservices. Fair enough, it's a presentation in 2006, but it's on the internet there, and it's being used. It's on the internet. Everybody will see it. Everybody does microservices, and you can even get courses about microservices by Google themselves. So why wouldn't you want to implement microservices? So how do you go about implementing microservices? Hip company and hip management want to do this. So what they do is they say, okay, let's do this microservices situation. Oh, and also we've got a bonus 3-in-1 buzzword. It's microservices, therefore you're going to be using Docker, and because you're using Docker, you need a container orchestration system, which obviously means you're going to be using Kubernetes. And again, Kubernetes is the big thing. You've got KubeCon, which has 10,000 people, so hip management is happy. They'll say, okay, we can send our developers to KubeCon so that they'll learn about Kubernetes. You can even get certified as a Kubernetes administrator. I am actually certified as a Kubernetes administrator myself. So yeah, you really want to do Kubernetes because you're doing microservices. You get the added benefit of using Kubernetes. So hip management goes, yep, let's do it all in one. We're going to be hip again. So what they do is completely misunderstand what that means. And that means you have your monolith, which is obviously connected to a database, and you break it apart. You've broken it into microservices, not really sure how, but they're microservices. It's smaller than a monolith, and you've got multiple ones of them. It's also running on Kubernetes, so you get the added benefit of that. But HIP management is looking at that and thinking, ooh, they're not really micro enough. I think we need to split it a little bit more. So our story takes us into even more microservices. Look at that. It's wonderful. They've got microservices all over, but they really need to connect to a database because they need the data. So they connect everything, it's all there, everything's connected to everything. It's a bit of a mishmash, not really sure what's going on. You're hoping that some microservices don't actually talk to the same schema and the same database, because otherwise it's a whole jumble. Somehow we've ended up with a microservice there which really is not really doing much apart from talking to the database. Why is it doing? But we're doing microservices, so it's okay, no problem. We're gonna be hip again. This is what they tell their developers. In the meantime, their developers are thinking, what are we doing? How are we doing this? Well, yeah, this is going to be fun. I'm going to have to learn about Kubernetes. Well, I get a free trip to KubeCon maybe, so who knows? Yeah, we'll do microservices. It's great. We can do microservices. After a while, yeah, stuff's still not working. HIP company still gets bugs into production. Not sure why. You've got teams testing out stuff and saying, well, I fixed my thing. I don't know why there are bugs. The devs blame the ops team. Ops, poor Fred, who's still trying to figure out more than the S3 bucket on AWS, is blaming the devs. Nobody really knows what's going on. And your deployments break half of the system. One microservice that talks to 20 different microservices shuts down about 10 microservices. And therefore it breaks half the system. And as we said, nobody talks to each other. There's no real going on. Not sure why the systems work. So HIP management wants to understand, well, but we've implemented microservices. Not only that, we've implemented microservices, Docker and Kubernetes. They're the buzzwords to use. What are we missing? Why isn't it all working? So again, HIP management goes back to their boardroom. They all huddle up around a laptop to talk, well, how can we help our devs and our ops to be better and to use microservices better? So they Google devs and ops better. So devs, of course, we'll implement DevOps. There you go. HIP management is extremely happy now. They've got their new buzzword. It's DevOps. I mean, look at that symbol. It just flows. It's a beauty. HIP management really want to implement DevOps. They're going to tell their engineers this is the way forward. With microservices and DevOps, we've got the buzzwords. It's all going to be beautiful. I mean, DevOps you've got the big cloud companies giving you DevOps. AWS, Azure, Google itself, they all give you DevOps. You can even go online, click one button, and you get automated DevOps. Who wouldn't want that? You get a state of DevOps on a yearly basis. Some manager gets a form who fills it in and they send it off and you get a state of DevOps. So HIP companies management is really happy. Yeah, we can look at that state and we can be better at them because we're going to be the DevOps microservices company. And as always, you can always get certified. You can become a DevOps engineer, whatever that means. And similarly to microservices, DevOps is a 3-in-1 buzzword. If you're going to do DevOps, you'll be agile. And being agile means you're going to ship extremely fast. It's going to be every 2 weeks, you're going to have a new system. It's not on a quarterly basis anymore. We're going to ship features, no worries. As soon as the customer wants it, here, get it. We're going to be agile. And because you're doing agile, we're doing Scrum. And Scrum obviously means having 2-week sprints, and in those 2 weeks you do your system, and at the end of the week you go, the release manager comes and goes 3, 2, 1, release, and everybody releases after those 2 weeks. You don't want to do it on the Friday because of Friday drinks. So there you go. You've got DevOps. We're all implementing DevOps, and DevOps and microservices will give us the lead. And it's all a spiraling rabbit hole of issues. Teams now own infrastructure, so therefore they do what they need for infrastructure as code. One team's using Terraform. Fred, who did the S3 bucket, is using CloudFormation. The another team is using Pulumi because they're software developers. They want to use software development tools. So it's all a mishmash. Nobody really knows what kind of infrastructure code they're using. The access to the DBs is granted to everybody and anybody who needs it. But again, you ship it, you own it. Therefore, I need to get access to the database. The teams don't really know. They start accessing other teams' databases. It's a bit of a mishmash. The secrets, nobody has talked about secrets or security, that they're all being stored on version control in Git and then pushed because that's how you ship extremely fast. You put the secrets in there and off you go. Again, the applications are talking to the database because we haven't really microserviced the database. You don't microservice a database. You microservice the services, not a database. So HIP management hasn't really looked into database structure. And there's no testing being done. Everybody just ships. Yeah, this 2-week Scrum is being released and no tests are being done because they need to hit those 2 weeks. So in the meantime, you've got your developers getting even more frustrated, and that's where you have achieved optimum level of annoyance, and you've infuriated pretty much everybody in HIP company. So our story ends with the developers just throwing tables away, not really knowing what's going on, and HIP company not really working. So that story, fair enough. It's easy for me to stay here and go, yeah, they're doing it all wrong. They're using buzzwords. So what can you do? What should you be doing? Well, the first thing you could do is not think about buzzwords. Completely forget about buzzwords. Do not use buzzwords. Easier said than done. I've spent the last, 15, 20 minutes here saying microservices, DevOps. I think I've said microservices more times in the last 20 minutes than I did in the last 2-3 months. So your brain is just shouting microservices. So how can I even forget about microservices? Well, it's similar to me telling you, don't think about the pink elephant. I'm sure the first thing you're thinking about is a pink elephant. And I think the solution to this was actually given to me by my partner who teaches 6-7-year-olds, as I was telling the people here. And it's interesting how she comes up with ideas of dealing with 6-7-year-olds, which is probably a good way to deal with me as well. It's once, if somebody tells you do not think about something, you need to immediately think about something else. So if I tell you don't think about the pink elephant, you go rainbow colored zebra. So now you're thinking about the rainbow colored zebra and not the pink elephant. Similarly, if I tell you DevOps, you should think communication between teams, well, maybe a little bit not, okay, you just shout communication. So this is where I don't think the virtual thing should have worked, because I thought I was going to go, I say DevOps, you all shout communication. So I'm going to assume you're all shouting communication on the other side. So I say DevOps, you shout communication. Similarly, I say microservices, you say modular. You know, the avant-garde 1970s programming concept of modular programming. So I say microservices, you say modular. Sam Newman, who actually worked with Martin Fowler at ThoughtWorks, writes in his microservices books, actually, how modularity is extremely important. So again, I say microservices, you say modular. So what can we learn from the story, from our HIP company story? And I'm hoping to portray these learning aspects from the story of HIP company. which not every company will have those issues, but they might find a few here and there. So the first thing HIP company didn't do was ask questions. They just said, okay, we're going to use microservices because that's what everybody's using. But you need to ask the questions, and you need to ask what, why, and how. So you need to ask what. What do I want to change? Okay, I've got the system, and what do I want to change? Okay, I want to change my monolithic application. Then you ask, why do I want to change that monolithic application? Is it because everybody's shouting microservices? I'd probably say turn back and rethink. Why do you want to change your monolithic application? Is it working? Yeah. So why do you need to change it? Well, I want to deliver faster because with a monolithic application, I just have to deliver one big thing, and I have to make sure everybody's talking to each other and coordinating one big release is a lot more work than just deploying a small aspect of the code. Okay, so we know why you want to do it. So what you actually want to do is deploy faster. You then ask, how am I going to do that? Similarly, let's say I want to change the fact that I have infrastructure being created from the UI. Why do you want to do that? Well, I want to do that because it can be version controlled. It can be repeatable. So I want to ensure that there is a log of what's happening to my infrastructure. Okay, how am I going to do this? You then do a bit of research into how. There are multiple technologies of how you could do this. You could do this with Terraform. You could do this, as we said, with Pulumi or CloudFormation. And you repeat those steps over and over again. Okay, we're going to choose Terraform, for example. Why am I going to choose Terraform? Well, it's the de facto infrastructure as code. Okay, well, why isn't CloudFormation better? And you do that, but through communication. You do that through communication with your developers. One thing HIP company didn't do was communicate with the teams. They just stood around in one room. HIP management decided, yeah, this is what we're going to do. That's how I'm going to do it. So you want to communicate with people. And you do this by gathering opinions and understandings. Doesn't mean that everybody's opinion is going to end up as a final step. But what you do enable is an environment of collaboration. If I tell somebody, oh, what do you think we should do, or how do you think we should do it, he's going to be comfortable with approaching me and collaborate with me a lot more. You also ensure that everybody has the same understanding of what the company is doing and where it's going. So that communication and trust enables that collaboration. Another form of communication is documentation, because once you have those opinions and understandings and you have made that decision, you're actually going to build whatever you've decided. And during the build process, you want to ensure you document what you're doing. Now, I know documentation isn't the most fun of things. Everybody has a part of the job they're not really keen about. I think I've only ever met one engineer who seems to truly love documentation. But then again, you couldn't get him to stop talking as well. So maybe it was his thing to document. But you need to document what you're doing. Not only for other people, but for yourself. I mean, I always say that after my slap, my memory bank has reset, so I don't remember what I did yesterday. So I want documentation to understand, oh, how did I do this exactly? How did I deploy that code? Why am I deploying it? That's also a very good reason to document, to tell people why you've chosen what you've done. But also in the documentation process, you're also going to try and give options. So HIP company didn't really provide any options. They just told everybody, yeah, we're going to use microservices. Had they gone through the what, why, how, asked questions scenario and still came up to, okay, we want to do microservices, what you want to do is definitely provide options. You want donuts, but you want a variety of donuts. So what they could have done is say, talk to the teams and ask who would be keen on trying out microservices. And by doing that, what you first do is ensure you don't break up the whole monolith into pieces all of a sudden. It's not one kind of big bang situation where everything breaks at once. What you do is you get a team to look into how do I want to do microservices for my little area of the monolith. How do I want to break it out? How do I want to deploy that? How does it need to talk to the monolith? How does it need to talk to the application? And because you're giving the option for teams to tackle that issue, other teams will look at them and see their enthusiasm into going for microservices, for example, and therefore get on board a lot quicker. So once you do that, you want to automate. You definitely want to automate as much as possible. This is where I go. You want to automate. I want to automate. Luke wants to automate. Everybody wants to automate. Automation is amazing. If it's a repeatable action, you're going to automate it. And humans are beings of repeatability. They'll do something, they'll like it, and they'll do it over and over again. And that means it can be automated. I mean, you want to be the guy who's sitting there in front of his laptop, hands behind his head, relaxed, chill, focusing on other stuff because he's automated most of his job. I'll tell you a real story, actually. So before I went into cloud engineering, I was an automotive engineer, which is a fancy way of saying I played with cars. And at the very beginning of my job, I actually, part of my job was getting a car from one of the clients. So we used to sell products to a client, and we wanted to make sure that the client is using that product in the specifications we set through multiple reasons, because of warranty, ensuring that our name is still viable, so on and so forth. So what you do is you tell the customer, okay, we're selling you this product. We want to see how you're going to implement it in your car, and we want to test it and check, and then we can sign off the warranty. So we'd get somebody like Jaguar, give us a car. I'd get the car, put a bucket load of sensors on our product, take a bucket load of data, give the car back to the client, analyze all of that data, and file my report. Well, what I didn't realize, and this was literally my very first job, what I didn't realize that during the testing session, one of the sensors had fallen. And because I hadn't automated a way to check the data I'm collecting, after the 2-3 days I had collected all the data and given back the car to the client, I eagerly went to analyze the data and saw a bunch of zeros. So it was a bit embarrassing to have to call the customer again and tell him, actually, could you ship the car back? Because the 2 and 3 days I did of testing is pretty much useless. I then spent about a week writing automated tests of the data I'm being collected, of the data is being collected, and also in the meantime, while I'm collecting that data, because I've stored it into a secure second place, so I'm making sure that my data is secure, I can analyze it as well, because I'm going to automate that analysis process. So something that took me 2-3 weeks before is now taking me 2-3 days, and I'm adding more business value. So you definitely want to automate, and you're going to automate your tests. Tests are repeatable. So you test, you write your code, you test it. You've got a unit test. You don't change your unit test every time you change code. Your unit test is pretty much consistent. So you want to automate those tests over and over and over again. You don't want to spend time testing. What you want to do spend time is writing code, adding value to the business. So you're automating your tests. Once you've automated those tests, everything is green. Everything is telling you, yeah, it's all good. You want to automate the builds. You don't really need to right, docker build -t if you're using containers or creating your jar file. It's all going to be the same command over and over again. And as you can see, it's going to be a repeatable process, and therefore you want to automate your builds. And once you've automated your builds, you want to automate your deployments. Your deployments are automatable. It's the same process, whether it's going to be an application in one programming language or another. Your deployments can be repeatable. The added benefit of automating all of that is that you don't have, you're not giving access to everybody and anybody to SSH into your machine and deploy them. It's only through a pipeline that you can deploy, and therefore you're increasing your security. So once you've got that automated deployment and your application running onto your system, what you want to do is get feedback. You want to monitor and alert, and you want to monitor everything and anything possible. So you want to monitor what your application is doing. You want to monitor what your infrastructure is doing. You want to monitor latencies, network. You want to monitor what your users are doing. How are they using your application? And you want to do this because you want to understand, can I improve on that? And that takes us back to your asking questions. What are they doing with my application? How are they using it? What, can I improve on it? And monitoring also allows you to alert on systems. So alerting can be both a good or a bad thing. It's alerting that, yeah, everything's going fine. You can sit down, you can relax. You want to alert engineers that their deployments have succeeded. You don't want them thinking, well, actually, I clicked the button half an hour ago. Has everything been deployed okay? You want to confirm that everything's still okay. Focus on your other job. But it also can tell you that things are going wrong. Maybe something's crashed, your website's down. I definitely want to have alerts telling you, see, things are going on. Things are not doing what they're supposed to be doing. You want to get Slack messages, emails, phone calls, pigeons, whatever possible you can automate. You want those alerts coming at you so that you can fix the problem a lot sooner. They can be a little bit smaller of alerts by saying, okay, my latency is X amount of milliseconds more than expected. Why? How can I improve on that? But one thing you definitely don't want to do is panic when alerts actually shout. So don't panic. Things might go wrong, but don't panic. Little Fred over there is who's still focusing on his S3 bucket on AWS, knows things are wrong and he is going to work on them. So keep calm, focus on the issue, and go ahead. So in summary, what you want to do is ask questions. Ask your what, why, how, and communicate those decisions you've made from answering those questions. So you can also get feedback from the people, and maybe you want to get information on those questions. So you want to communicate with your team. Once you've communicated with your team and have decided what you're going to build and how you're going to build it, you want to automate every single step afterwards. You definitely want to automate your tests, because your tests will tell you if you can proceed to the next step or not. If they go red, okay, let's communicate with the team again and re-automate those test procedures until they're green. You automate your builds, and then you automate your deployments. And as we said, that has the added benefit of being secure, because you're not allowing everybody and anybody to access your machines and your infrastructure. And once you've got that running and they're all deployed and it's all running, you want to monitor and alert your application. You want to monitor and alert your application because if anything goes wrong, you can act upon it fast. Or if you want to look at something and ask your questions of what, why, and how, you need that information from your monitoring application. And then once you ask those questions, you can go into that loop, which to me looks very familiar. I seem to have seen it somewhere. I don't know, you might have an idea. I'm sure I can come up with a good buzzword for it. And finally, as I said, things are going to be difficult. This will take time. Building a tanker that can do a circumference in the sea that quickly, that fast is difficult. The engineering involved to design something like that is extremely big. You'll need experts, and this is where maybe you'll want to get outside experts telling you, okay, you want to focus on this and that. You don't build the tanker all at once. You build the rudder, you build the engine, you build the electronics and control center, then you build the bow. Similarly, you don't break up that monolith all at once. You do pieces by pieces. And finally, also, things will go wrong. Everybody makes mistakes. Similar to the cargo ship over here who thought shipping through a typhoon might have been a good idea. Things will go wrong. And it's useless pointing to people, why did it go wrong? What are you doing? Okay, let's learn from that, which is where your monitoring, logging, and alerts come into action. I'm sure they learned that going through a typhoon without your containers properly wrapped up isn't the best of ideas. So again, it's going to be a difficult process. Taking something like a monolith and breaking it up is going to be difficult. And if you're going to touch your database and you need to separate the database, that's going to be even more difficult. That's where the fun might start, and that's where you might actually need to get expertise involved. So I hope you did like the presentation, and you're now buzzword compliant. So I don't really use Twitter that much, but I'm going to start using this hashtag of dev git sec infra no biz AIOps, which flows out of the mouth extremely easy. But that's the new buzzword to start using. I think this can encapsulate all the buzzwords we're facing today. So you're now buzzword compliant. Thanks. And if you've got any questions, feel free to message them. Because asking them to me over the screen is not going to work. So let me see. Yeah.
Yeah, we'll keep the mic in between us.
Yeah.
Thank you, Tim. We indeed got 2 questions. I'll ask Tim to repeat the questions from my phone. This is all professional production. So here we go, Tim. 2 questions.
Okay. How do you think productivity relates to following all the buzzwords? How do we keep focus on productivity? Well, I think I don't know when these questions came. Did they come in during the process and not at the end of the talk?
Yeah, a personal thing.
Oh, right. Okay. So they came in throughout. And I think my last bit of a slide kind of is showing you how you can keep productivity going. It's doing those things, but without the buzzwords. You're not really. I mean, obviously, the joke there was that it looks like the DevOps symbol, but you can do DevOps without saying DevOps. You can be productive by doing all these steps. So how do you think productivity relates to following the buzzwords? So it's not following the buzzwords. It's more doing those actionable items that will improve your productivity. So therefore, decompose that buzzword into, for example, DevOps actually being asking questions, communicating, automating everything and anything possible, and monitoring what you're doing. That can definitely improve your productivity. And the last one is, do you think that buzzwords are inherently bad? So I think at Skyworks, I'm probably the one who every time somebody says DevOps or uses a buzzword, everybody looks at me and goes, "Oh, Tim." So I don't think buzzwords are inherently bad. It's how they're used sometimes that make them bad. It's saying, okay, we're gonna do microservices and splitting up the monolith without actually understanding what's going on. I think microservices are great maybe not for startups initially. But I think microservices are great because it allows fast deployment, for example. So microservices is a good concept. It's how you're going to use that concept. DevOps is actually a really good concept. It's a methodology. You cannot really be a DevOps engineer. You need to implement the methodology of DevOps. The issue here is if people take the word DevOps and say, okay, we're going to do DevOps all of a sudden. Okay, what does DevOps mean? That's where the buzzword becomes inherently bad. But they're not that bad. Yeah, I think that's pretty much it.
That's cool. Right. Well, hand me the mic. Thank you, Timothy. That's wonderful.
Thank you.
We got the applause is going. Well, this means that we are into the intermission. The intermission will be 10 minutes. This will allow us to go to the toilet, get a fresh cold beer or soft drink, whatever is your preference. And then after those 10 minutes, which if I look closely is 10 to 7, Daniel will start with his talk. And do ask your questions in the chat because we'll gather them and ask them at the end. So thank you and see you in 10 minutes. There we are, back again, 10 to 7, the Codebeez Meetup. I think I missed an L there, but it's Daniel with an L. Title, Django in Serverless Land. This is the Python Codebeez Meetup, if you just checked in. And I want to give the word to Daniel, so go on. Here's the mic. Let's see. Let's switch the slides. There you go.
So let's start. Thank you guys for having me. Thank Codebeez. I'm Daniel. I'm senior Python developer at Codebeez. Codebeez is also a constant company specialized in Python. We partner with several different companies doing mostly Python and all kinds of sort of Python, from machine learning, web development, you name it. So who wants to learn another buzzword? Yeah, so after this talk team about the buzzwords, there's this new buzzword that everyone is talking now that I think you forgot to mention that thing, but it's really in the trends, that's serverless. So let's try to understand a bit of serverless and how does it work and how does it fits in your workflow. It's like Tim said, like, it's good to understand this buzzword, understand what they mean, what they actually are, not just follow what is happening. So I hope that in the end of this presentation you can have a good understanding of what's serverless and if serverless is the right thing for you, or if maybe not. I'm gonna cover a few topics. This thing is more focused on Python, so I'm gonna go with provision versus serverless and what's the difference, what are these models having different or in common, and how you can decide which one to choose. And besides that, we're gonna focus on AWS and Zappa, two tools to help you to go to this serverless land, to this serverless application. And these two, AWS and Zappa, they work together to make your familiar Python code to work on the serverless architecture. So serverless is this execution model that makes your code be executed on demand. So you don't have to provision anything, and it just works when you need of it. When someone requests your code, it's gonna be executed. When no one's requesting, it's not working. So you don't have to pay. That's a good thing about it. And of course, there's also challenges and limitations of serverless. There's challenges and limitations of AWS using serverless. So each one you have to analyze if this is the right choice for you. So first thing first, we need to understand why serverless became this thing and why people are talking about serverless and why. What's the problem with the provision model? There are some issues of the provision model. What things serverless are trying to solve? And when you have this provision model, you have to say exactly what you need. And you have maintenance. You have to have high-skilled people to maintain and to understand what are the needs for the load that they are having. And you need to handle updates and security patches, everything for yourself. So it's everything that you have to do by yourself, by your company, by a specialized team, and you also pay for idle time. So if you have if you have your application and no one is accessing it, no one is doing any request, but it's still running, or you forgot that thing, and you are still paying for that. And this, of course, can increase your costs, to the sky. So that's why serverless came into place, to try to solve these issues with the provision model and try to make the going from your environment to deployment and to scaling as smooth as possible. And yeah, of course, when you have provision, you also have to handle the scaling, the availability. You have all these things, all this puzzle of the environment of the DevOps operations. You have to handle all these things. In the spirit of there is no cloud, it's just someone else's computer, there is this tweet that says there is no serverless. It's just someone else fully managed execution environment. I only pay a fraction of a cent whenever my function is run. So of course, serverless is also a buzzword. It's a word created to make people look at it like, no serverless, no SQL, all these things, agile, these words are marketing words, trying to sound like, okay, oh, it's serverless, so I don't have any server. But of course, I have a server. I just don't care about it. I don't have to worry about that thing. I don't have to maintain. I don't have to be worried about if it scales or not. It is, but the server is there, and someone is taking care of it. So you have zero maintenance, zero downtime, lower costs, and it just scales. Is by default, by design, it just scales. You don't have to worry about the scalability or the availability. AWS is taking care for you. And I'm just talking about AWS. What AWS offers as serverless applications or serverless solutions. And it's hard to say because it's always changing, and AWS is always adding more and more things, like Google Cloud or like Azure. They're always trying to make evolving things and introducing new tools every time. But here is a picture of a few of the main applications that you can find for serverless. So you have Lambdas is one of the main things for computing. So Lambdas is a function as a service. Lambdas runs your code on demand. So when you need some execution, it creates the container, executes your function, and then when you don't need it, it doesn't exist. You have S3. It's probably the first interaction of most of people with some serverless concepts are in S3. That is this concept of storage as a service. You don't care about like how where the S3 is storing your things or your space available, or you don't care. You just store your things and they are there. It just works, and you pay for what you use only. But besides that, you have a lot of other things. Coming from authentication using Cognito, DynamoDB for database. You also have relational database with Aurora that are they are interoperable with Postgre and MySQL. All these things are serverless. All are these things you don't care. You don't care about the maintenance. You don't care about the availability and the scalability. And it works for a specific use case, or for a use case that you know exactly that a specific use case that you can run this and get a lot of benefits. Things like when you have a variable load. And you're going to talk about this in the next slides. The first thing I mentioned there about this, the serverless is the Lambda. Lambda is a function as a service. A function as a service is a very nice name for a code that runs only when you need, and you don't pay when you don't need it. So you pay as you go, serving computing on demand, and it scales as needed. So if someone today, if your code is requested 10 times today, it runs 10 times, and you pay for the 10 times. If tomorrow it gets 100 requests, it just scales for 100 requests, and you just pay for the 100 requests. If the next day no one requests your code, you don't pay for it, and your code is sleeping. And of course, but not everything is perfect, and you need to understand what are the limitations and what are the challenges that comes with it. And of course, Lambda has their own limitations. I'm talking specific about AWS Lambdas. Of course, if you go to Azure, they have Azure functions, and if you go to GCP, they have their own functions on the cloud as well. And all of them have their own limitations. AWS has some limitations, like a timeout of 15 minutes. This is for now. They used to increase it. It used to be five minutes. Now it's 15. but this timeout is 15 minutes for the Lambda execution and 30 seconds for the API gateway. So if you need to connect your Lambda to an API gateway to serve a web application, you need to understand that it has a 30 seconds hard cap, 29 seconds to be more precise. And there's a limitation of memory allocation and in concurrent executions. The concurrent executions you can ask for increase from AWS, but by default it comes with 1,000 concurrent executions per region. There is also another page that you can check there, when you can see all the limits available on AWS, and it's nice that you can see this when they update and if there is any change or any increase on the limitations, you can see on this page. So we talk about AWS, we talk about serverless. Now let's talk how we can get the Python code into this architecture. The familiar Python code that we're used to. And that's why I present you Zappa, not that one, but a tool that helps you get Python applications, WCGI applications written in Python, and convert it to a serverless architecture in just a few steps. It's really, really simple with Zappa to build and deploy to AWS and to migrate your current Django, Flask, or any other WCGI application to serverless. It comes also packed with a very powerful command line interface. This command line interface allows you to do all sorts of commands, including doing Django management commands in the cloud. So how does Zappa work? I talk about some of the services on AWS, and Zappa just get the services together and make it easy for the developer to deploy and to manage their application. You can see on this picture, we have a S3 bucket on the top connected to a Lambda. The Lambda accesses the code on the S3 bucket. So your code will be deployed to an S3 bucket that the Lambda will run whenever there is a request in the API gateway. So remember what I said about the API gateway hard cap on 30 seconds? You need to make sure that your code will be delivered in 30 seconds. Otherwise, you get a timeout. The function is still running, keeps running after it returns already a timeout response from the API gateway. So all these things is like glued together with a settings configuration file that you can see a snippet on the screen, where you can define your environments like dev, staging, and define your configuration there. You see the S3 bucket that is defined, and the Django settings is an example. So this thing puts together and you deploy, and it just works. Really, it's a really, really hand tool to get your familiar code, the thing that you are used to. You're used to write Python, we're used to write Django, Flask, and then put it on a serverless architecture and get the benefits of this serverless architecture. Here is a few commands that you can do using the Zappa command line. When you go to your code, you just run Zappa init, and then it recognizes if your code is a Django or Flask and set up your configuration file for you. So you pretty much, you have to do very, very few things to make it work. Most of the time you do Zappa init and you can deploy already. Here is deploying to production, but you can deploy it to any other environment. To define the environment and then just deploy. After the first deployment, you can just run update to update your code. The deploy is just for the first call, and then you run update every time you want to update your code. And you can also run rollback. Another nice thing is that you can do a Zappa tail to get the logs. which also has a lot of power command lines attributes. You can filter, you can get specific logs that you want. You can get a time period. And another nice thing is that you can run Python manage commands directly from the Zappa command line on the cloud. You run that command, some black magic happens, and then you get your information. If you go to the Zappa web page, there's a GitHub, and it's really, really well documented. You have most of the things that you're gonna need and and all the settings, saying everything, how it works and which setting does what. It's really, really well documented, so it's very simple. There's also things like running asynchronous commands. If something takes more than 30 seconds, you can run it asynchronous. You can integrate it with another AWS events. So you can do most of the things like infrastructure as a code in the Zappa configuration. So you get your code, your Django code, and in a few minutes you have your code on the cloud, on a serverless architecture, and you can already get the benefits of the serverless architecture. But maybe a few things can go wrong, of course. It's not always like smooth. Sometimes you're gonna deploy, you run Zappa in it and then deploy your application, but it's not working. What can go wrong? Famous last words. Serving static files might be an issue because the Zappa doesn't serve static files. So you need to find a different way. You can serve them from S3 or using white noise, but it's not going to serve it by default. But the nice thing is that if you go again to that amazing website of Zappa, and then you search for static files, and they have a specific topic about serving static files. So it's pretty straightforward, and they recommend to use Django storage or Flask S3, depends on the case. If you are using another framework, you probably are familiar with some library that connects them to S3. And then you can follow these things and just, it's in just a few steps you can fix this, and then you can serve your static files. Another thing is external internet access. If you're running your functions inside a VPC, a private VPC, and you're not going to have access to internet by default. So if your code for some reason needs access to the internet, you need to define a route from your VPC to the external internet using a net gateway, internet gateway, to make sure that the internet, the thing that you need, is accessible. Or you can use also VPC endpoints if you're using a specific AWS service that run on the internet, that you have to access over internet. Another thing is that, can you imagine, like, when you have this scenario, like, of a lot of lambdas being execution, and you have a lot of opening connections to database, closing connections, opening connections, it can exhaust the database. To manage the connection pool of serverless application can be exhausting, can exhaust the resource of your database, and might be an issue. Recently, AWS introduced database proxy for these situations. That's why I said that's always nice to keep a look on the news from AWS, because they're always introducing new things, and now they are very into serverless, very into adding more things for serverless. So yeah, if you look at that, there's always some things that improve the work that have been done on serverless. And then we come to one of the main issues with serverless: cold start. First, you need to understand what is cold start. There's cold start and warm start of your Lambda function, or your database, or whatever serverless thing you are using. If if your application is sleeping, no one is accessing it, the first access of it, they need to do all the initialization, creating the container, initializing your application, setting up everything that it needs for the environment to run, and then run your application. And then it can have a delay. It can have it adds latency to your request, and can be an issue in some case. Until last year, there was a big issue with private VPCs, Lambdas running inside of private VPC, because the Elastic Network interface creation took so long. It was taking 10 seconds or so. So you can imagine, if you have 30 seconds of a hard cap, and then you have 10 seconds only for the initialization, then it might happen that your application is not going to respond in time. But now, AWS fixed that thing. That thing is amazing now. You can run on your private VPC, and it's very, very fast. If you're running an interpreted language like Python, JavaScript, it's also really fast for the language startup. You don't have compiling time. So it's less than 1 second for the startup. So this thing all this cold start can add to your application. So it's something that you have to keep a look. How you can minimize, how the other things that you can minimize to your cold start. First thing, Zappa has a function called keep warm. By default, it tries to run your application every 4 minutes. You can change this value. So it tries to keep your function on warm start. You can see this it's very simple. It's just in a configuration. If you go to the configuration, you can see there is this keep warm. Create cloud watch events to keep the server warm, default true. And you have the keep warm expression saying when it's going to run. It's by default for 4 minutes, but you can change it. And of course, it tries to keep your application like warm. But there might be other issues, like okay, you have one instance like warm, but if more people are requesting, you have to create other instance, other containers, other things, and it's still cold start. AWS provide now a solution called provision concurrence, so you can by default let some concurrence warm on your server. You can increase memory, and when you increase memory of your Lambda, you increase the CPU power, and with that, your application might run faster. In some case, you're gonna pay less, even because your application runs faster than when it was less memory. Even you paying more for the extra memory, the time of running your application is lower. So it's always trade-off. You have to look at exactly your situation, your scenario, if it's better to increase your memory. But then comes another thing. Not only Lambda cold start can be an issue. Also, if you're working with a relational database, of RDS, there is Aurora. That is the MySQL Postgre version, serverless version. And these things can take up 20 seconds for a cold start. And of course, 20 seconds and third, your 2/3 of your application is starting up the database. Can be a big issue. There is a few things that you can make now to fix it. There is defining a minimum number of units of your database. Instead of 0, define always 1. But then, of course, you have a cost penalty. You always are paying at least one instance of your database running, and the cost for the serverless is more expensive than the provision per minute, per second. So you end up paying a lot more. But in some cases, if your application has to handle a lot of scaling, upscaling, downscaling, might be a good solution, because you don't have to worry about this. You just select the minimum. You have the minimum, but you don't have you can scale up and you can scale down without anyone having to worry. And there is another thing that AWS introduced, kind of new. That is the RDS Data API. That thing promises you connectionless queries to the database. When you check the box when you're creating your database for having this, you can first you can use the console, AWS console, to query your database, your serverless database, and you can do the queries without having to do this startup. So it's way faster. However, until what I saw, there is no transparent way to connect what you are using to. You have to use the API, the AWS API, to do these queries using the data API. It's not something that you can just plug into Django RM or SQL Alchemy and then having this running. So maybe in the future someone will do something like that, and that'll be really cool, because it is one of the main things of having a relational database running on a serverless. So I think now you pretty much have a clear picture of what is serverless, how Django Python goes into that, what are the benefits, what are the not so good things, the bad things. So when you have to go serverless, when you decide to go this way, when you have variable loads, when your application can go run from a 0 requests to, I don't know, 20 requests or 100 requests per minute. You don't know, the variable can change a lot, and it can be a really good solution. At Codebeez, we have developed an internal tool using serverless, and because it's used most of the time, like in two days of the month, pretty much. So during the time that you're not using, this is not being paid. You don't pay for that thing. And also when you have things like staging environment, test environment, things that you access just when you are testing your application, or just when you are doing some presentations or something, and then these things are not accessible, and you have a tolerance to some things like timeouts. Okay, you can have a relational database, or you can go to DynamoDB, that is the serverless database by default from AWS, that don't have these problems of cold start. But then in that case, with staging that you are tolerant to some timeout and have to refresh the page, you can just go there, and you're gonna pay just a fraction of you are paying probably. So another benefit, of course, is the inheriting outer scalability. So it's just scale up, scale down. You don't have to worry about that thing. When you need more instance, they are created for you. When you don't need them, they are killed. And it's also developer friendly. It's something that your development team doesn't need to have DevOps operation or a high specialized team in maintenance or something. They can just work with the serverless and deploy their code with pretty much very few friction. And there is the thing that probably makes the eyes of the manager, of the CEOs too bright, and the cost reduction. And in some cases, you can have your application running for a fraction of your paying before, just because of you went serverless. And this thing can have like you can pay like an order of magnitude less than what you're paying. Depends on your use case. That's you need to analyze yourself and see if your use case is gonna benefit from that. I mentioned about the AWS always adding new things. If you go to this website, aws.amazon.com/new, it always gives you everything that is new into the AWS. There's all update, digital course, architecting our serverless solutions. So as I said, they are always pushing something about serverless recently. So there's things about serverless very, very, very new, brand fresh on the main page. So if you can search if you want something specific. So they are always introducing and improving their solutions for serverless. So keep an eye on this thing. It's really, really cool. And there's something that maybe is not the best solution 2 months ago or 3 months ago. Maybe now they they have fixed it or they have improved it in a point that it fits your use case. So I hope that having all this in mind, you can understand when to go to serverless, when you can decide, well, you should go to serverless. But also there are challenges, of course. It's a new thing, and as a new thing, it's still unexplored. You don't have that many people around yet, like with like solutions or design patterns very well established. It's something that if you like to explore, you can go there, but there are still things that people are not very sure, or we don't know exactly how it's going to pay off in the future. And also it's very unstable. The new tools and services are added all the time, like I said. This is a good thing, but it also means that we haven't gone in a stable environment yet. We are still trying things, and seeing what works and what doesn't. And there is another big challenge, that is a vendor locking. When you go serverless, most of the time you are very strict to a vendor. Like most of the things all the things that I showed today was AWS related, was pretty much AWS, how AWS does the thing. And you have to use specific AWS libraries. You have to run specific AWS patterns. And this thing can be an issue if you want to migrate to a different thing in the future. If you're running like Kubernetes, you can go GCP, you can go Azure, you can go AWS in not so many steps. But if you're doing serverless, you are very much attached to that vendor. And yeah, this can be a problem if you are not want to take that risk of deciding to one specific vendor. So all these things, I hope it can clarify for like if this buzzword, this amazing buzzword of serverless, is something that fits your use case or not, and if you can decide if you should go on that direction, if you should try, if you should, or if you don't have any benefits from it. So I hope you have understood what's serverless, how does it work, and how you can benefit from it using Django and Python. Thank you.
Thank you. Thank you. We got a couple of questions, Daniel.
Yeah.
We got some real applause here. Yeah. Just look at the questions. Please repeat them for the audience. Yeah. Like do 3 or 4 of them.
Does serverless let you focus more on being a developer than an infrastructure person? Yes. I think so, yeah. It's something that lets you do way more development thing, and doesn't care much about the infrastructure in a way that you understand how it's going, but you don't have to do auto scaling, you don't have to manage your clusters and your configuration. You pretty much hand all these infrastructure services to your provider. The availability is not something that is in your hands. It's something that you outsource it to your provider, to your cloud provider, and then you focus on your development. Can you combine serverless and serverful within the same architecture? Yes, of course. You can even use the same application that you can have different environments for serverless and server. You can have a database that is serverful, and a database in an application that is running on a Lambda. You can do all kinds of combinations. If for example, if you want to have your web application running on the cloud, on a serverless, but you don't want your relational database to be on serverless, you can do that. You can have a relational database managed, provision, and then you can have your application running on Lambda. Yeah, so serverless sounds like the magic solution when and in which scenario serverless is not the best choice? When you have a very stable load of your application. When your application runs a very stable load, I don't see like serverless in this case can add more costs than you're gonna pay with a provision. And you don't have to have a lot of auto scaling, things like that, because it's a very stable situation. So in this case, it's one of the cases that is not, and also you have to see the cases that the price doesn't worth it. Like when adding a database with a minimum of 1, and then you have to pay a lot more than if you have a managed database, provisioned database. And there, you have to analyze each of the situations, because serverless also has the latency that adds on the cold start, and in some cases your customer, your user cannot tolerate some changes in the latency. Maybe the latency is not, it's not something that, and sometimes even a timeout, and if your serverless application is like giving timeouts, and of course your customer won't accept that, or your user, it's something that is not going to fit your use case. Is serverless also available on other platforms besides AWS? Yes, of course. Azure has Azure Functions and all other kind of services. I think GCP has also Cloud Functions, if I recall correct the name, and also a lot of other services, and they have Firebase for authentication, so that is similar to AWS Cognito. So all the providers are fighting in the same area, so you can choose the one that fits better for you, or the one that provides better benefits. The issue that I said is like most of the time you are locked into your provider. So if you go from the start to GCP, you're gonna have to stay because it's not gonna be very, very easy to migrate to a different serverless architecture. I think that's it.
Okay. Oh, thank you.
Thank you.
Well, let's do this on screen. We got a big present for you.
Oh, thank you.
Take it home. I'm not sure what's in it, but it should be good. Yeah.
Nice. Thank you.
I'll take the mic. Yeah, Timo, come on screen. For people at home, we got some for you.
Cool. Well, thanks.
It's COVID proof, and this we won't do a handshake. I'm sorry.
No, I'll give you the
chicken handshake.
Chicken
we
shake.
got it.
Thanks.
Yeah.
Thank you.
So thanks to those two speakers. That's all. Also wraps up the content, of course, of this meetup. And what is left is to thank you for your attention and your time. We haven't planned our next meetup. We will let you know. What we do hope is that the next one will be allowable to have physical guests. Maybe, I don't know what the future distance will be. At the moment it's 1.5 meters. Well, the new office can accommodate like 5 people on that distance. So our startup has to grow a bit more before we have a successful meetup with 1.5 meters. But times will change. We'll see. Maybe next time digital, maybe physical, who knows. See you next time. Thank you. This is the end of the Python meetup by Codebeez on the 11th of June. I'm checking out Luc van der Velde. Thanks to the crew. Thanks to the speakers. Round of applause. Good night.